Hello, ma'am.
Hello, sir. Solling, sir.
Can you hear me? கேக்குதா ma'am?
கேக்குது sir. Voice okay, sir. Audible இருக்கு sir.
Voice clear இருக்கா ma'am? Low-ஆ இருக்கா? Low-ஆ இருக்கா?
கொஞ்சம் வந்துட்டு வால்யூம் இன்க்ரீஸ் பண்ணா நல்லா இருக்கும் சார்.
இப்போ ma'am? Now?
Okay sir. Clarity இருக்கு.
Oh, fine.
Okay sir. Then screen share பண்ணி check பண்ணலாம்.
Okay.
Okay.
என்னன்னா இப்போ உங்களுக்கு மெயில் ஐடியும் ஃபோன் நம்பர் மட்டும் காலேஜ் ஐடி ஃபோன் நம்பர்
ஓகே சார் ஓகே சார்
ஃபைல்ஸ் ஷேர் பண்ண முடியுமா மேம்?
இப்பயே ஷேர் பண்ணிடுவா சார்? பார்ட்டிசிபென்ட்ஸ் வந்ததுக்கு அப்புறம் ஷேர் பண்ணலாமா சார்? ஏன்னா
இல்ல நான் இப்போ ஏதாவது ஐ வாண்ட் டு ஷேர் சம் ஃபைல் நான் பண்ண முடியுமான்னு கேக்குறேன்.
கோ-ஹோஸ்ட் பண்ணிருக்கோம்ல சார். ஐ திங்க் பண்ண முடியும் சார், பண்ண முடியும்.
ஓகே, அது வேணும்னா பாத்துக்கலாம். இப்போ நான் ஆல்ரெடி சென்ட் பண்ண ஃபைல் மட்டும் நான் சொல்லும்போது நீங்க
நான் வந்துட்டு கொஞ்சம் பார்ட்டிசிபென்ட்ஸ் வந்ததுக்கு அப்புறம் நான் அந்த chat box-ல நான் கொடுத்துறேன் சார்.
ஓகே ஓகே ஓகே
ஓகே சார்.
10 o'clock கனெக்ட் பண்ணிக்கலாம்.
ஓகே சார், ஷூர். ஓகே, தேங்க் யூ சார்.
தேங்க் யூ.
Yes, answer and attendance, Prabha. Ravinika.
A very pleasant good morning to one and all present here. This is the way you start the morning can forecast your whole day. So without good vibe, let us start our day 3 SATP series of Vision Intelligence using Artificial Learning Phase 1. I thank all the participants for the continuous support and participation in this event. I thank our Honorable CEO, Sri Sairam Leomuthu sir, for arranging this event, and also I thank AICTE for sponsoring this event. I thank our respectable principal, Dr. K. Palanikumar sir, for his utmost support in organizing this event. And I thank our coordinator, Dr. B. Sridevi ma'am, Department of CSE, and our co-coordinators, Jayachandran sir and Rajalakshmi ma'am. And I welcome all the participants who have allotted their precious time for this event. We have eminent speakers from various institutions who have been gathered here to share their views and knowledge about the topic in this session. So here we have Dr. Sri Sairam, our session speaker. So he has done his PhD from Anna University, Chennai, and he is currently working as an assistant professor in Anna University, Tiruchirappalli. He has conducted an international conference of computational intelligence and a national conference on recent innovations in information technology. He has also organized an international conference of computational intelligence and a national conference on recent innovations in international technology and a technical symposium. He has specialized in the areas like cloud computing, data structures and algorithms, web programming, data structures, and advanced Python and applications. So without any delay, let us welcome our speaker. So I welcome you, sir.
Sir, mute and then.
Sir, your mic is in mute.
Oh, it's okay.
Yeah, sir, it's okay.
Good morning to everyone. I'm Shankaram from Anna University, Trichy. So today I'm going to take this session. This session will be very live and hands-on. So if you are using your mobile phone, don't worry about it. I'll share the entire code. It's better you may use your laptops. So let me start the session. So am I audible? Can you hear my voice?
Yes, sir. Yes, sir.
Yes. Okay. No problem. Okay. So simple implementation of a machine learning model to predict living room humidity. So this is our title. So today ML is ruling the world. Lots of technologies follow ML like industry, transportation, energy, agriculture, logistics, and medical, etc. So even in our house itself, we can make it very perfectly. So in this session, we are going to prepare our own data set, then upload it and apply it to the machine learning algorithm. Then we will take output. So hope you guys, every day you start the session with what is machine learning and what are the applications, what are the categories, and some examples with the machine learning algorithms. So this PPT is very simple PPT. Then this is very simple introduction. So within 5 minutes, we crossed it, right? So machine learning means, so we just make the machine to learn something, right? So what machine learning do actually, human learn from past experience, but machine follow the instruction given by humans. So a man can instruct machine, but the machine will not ask you anything actually. Yeah, until you just give some instruction to ask any question, then it will ask you. So what if human can train the machines? So if we give some data to the machines, then it will learn the data and it will take some decision. So human can learn from experience, then the machine can learn from the data. Simple. So there are two main categories: supervised learning and unsupervised learning. So from the supervised learning, I have given some animals and bats, duck, and a rabbit and something. Okay. So in supervised learning, actually how the supervised learning works, it is actually the given data is perfectly labeled. So once we have labeled the data, then it will just find it out, just this is that, this is rabbit and something like. And then what will your unsupervised learning do? So unsupervised learning means actually the data in the data, we have given some remarks of this. So if I'm saying this is duck, then if this is like this, then this is duck. If this is like this is rabbit. If the so the same, the machine will cluster it and give it to you. This is duck, this is rabbit, like this, right? So simply, what is linear regression? Linear regression allows us to quantify the relationship between two variables. So we know this very well. This is a very simple model. Then they are the variable, two variables are, one is dependent variable and another one is independent variable. So today we take the independent variable as temperature and dependent variable as humidity. So let me show on video. Before that, we are going to prepare this data set. In this data set, are you able to see? So you are able to see here the unique ID followed by the actual timestamp with the date and the actual temperature value and humidity and dew point is available, right? This is our data set. Totally 600 to 700 data rows are available. So this is the data what we are going to prepare by the Python program. Let me share some video. So what's the outcome of our data set preparation? Actually, we have given some data from the Python program through GET request, HTTP GET, then send the data to Google script, actually like this. So I just type this Python dataset.py. Actually, I'm executing this program. Then you can see in the Google script, Google Sheets, the data is dynamically filled. So actually the unique ID, date, time, temperature, humidity, and dew point. So let's see how to start this. So actually we will have 2 lines of Python program, only 2 lines. In that Python program, we just import our request library and responses or get request. So get request of what actually? Get request of, we have given some values. Excuse me. Fine. So get request of some, we are going to given some data through get request. So through the HTTP GET, we can send the data from client to the Google Sheets. So we are going to write this code from on the Google Colab. So just open your Google Colab, go to your Google account and parallelly open a new tab, type Google Colab. I just share the screen. So I just opened my Google account, and in another tab, I just type Colab. It's loading. Then open a new file. Actually, I just go here. I just name it M as ML model. Dear friends, are you following me?
Sorry to disturbing, sir. Sir, actually, the desktop screen is open, so the file is not shared.
Is the Chrome browser is visible, ma'am?
No, no, sir, no,
No,
sir.
no, no.
The desktop window explorer is open. So better you can close the sheet, that is, close the browser, then open it, sir.
Okay. I think now it is visible. Are you able to see my browser?
Yes, sir, yes, sir.
Okay, no problem. Here I have opened a new notebook. Fine. Just type import requests. Please follow me. Just type import request and just I execute it. Yeah, it's executed. We want to check the imported request module is working or not. Actually, I have given the response equals requests dot get. Just make a get request of google.com. Just type here https://google.com. Type So it's work. So have you got this? I just type only 3 lines. I have imported the request module. The second line is response equal to request.get of just a simple Google website I have called. I have make a get request and I got response as 200. Like this, we have to send our data to Google script and make our data set. So no problem if you are not following me. At the end of the session, I'll send you the entire code. So please follow me. Then we just, I have given on a URL, then just paste the URL inside the get function. Then we will send the data from here to Google script. So madam, please share the code, ma'am. Share the URL.
Okay, sir.
So what we are doing is just paste the URL inside the get function. That's it. It's not complicated, very simple. So I have typed at the end of the URL, just typed 33H34. Just assume that the first value 33 is our temperature and H is your delimiter and the last value 34 is our humidity. Just execute this. So I just remove one. I have added 2 double quotes. I have removed it. Now it's executed. Again, I want to check the response. Yes, it will give the response 200. So I have added the Google App script in my account. So you are able to see the result only here. I just type in another tab, Google Sheet. So these are the values I have added. So I have added 50 values, 50 rows. So if we are adding again, yes, the sheet is filled actually. Someone is sending request, but you are wrongly sending the data. So what I did is I just add the values at the end of the URL. After that, I have put the double quote at the end. So yes, you can see the data is dynamically filled. In this manner, we have preparing our data set in Google Sheet. So again, I just send the request here. Please note the timestamp. Now it is executed. I just type 33H34. So this row I have added. The date is given at the timestamp followed by 33, 34, and the last value is dew point. So what we did here, we just send the temperature and humidity value only. So in Google script, in the app script, inside the app script, I have added the code like actually at the time of sending your data, I have created the timestamp and the date. And at the end of at the last row, I have added some code to calculate the dew point from the temperature and humidity. That's it. So like this, we are preparing our data set. So in the last week from itself, I have sending this request and I have collected the data set for you. Then I'm sharing with you. Then you can use this data. So another part is how to add a Google script. So I will share another video. In this video, you can understood how to write app script in Google App Script. So up to this, so you are seeing the dynamic data is filled here. To this, have you asked any doubt? Hope this works fine. Is the video visible? The video visible? Or
No, sir.
again?
No, sir.
No, okay. I just close the browser and share it.
Okay, sir.
Yes. Now it's clear?
Yes, sir. Now it's visible.
Okay. So I'm opening new Google Sheet. So go and click the blank sheet. At the top of the page, just rename the file. By default, untitled spreadsheet is there. So I have added our attributes, unique ID, date, time, temperature, and humidity. So for the readability, I have added some colors. So once I have added the color, what I did is just go to Tools tab and click Script Editor. Go to Tools tab, go to Script Editor. So I'm going to add some code here to get the data from our Python code. We remember data will be sent via URL in the Python program. So through that program, we will getting the data from user. So actually, we need to add two functions here. The first function is function do get, then another one is get data. We will define the do get later. Then I just add the reference of our Google Sheet here. So in the sheet itself, we are going to add our data, right? So the first step is I just add the reference of the Google Sheet here. So how to do this? Just go to your Google Sheet you have created earlier. So yes, I came here and I just copy the URL at the address bar, copy the entire URL and came here and paste. Okay. So in your Google account, you have created your own Google Sheets. Then that URL you have to copy here. So the reference is created successfully. So the reference name is var sheet I have given. Then we have created our unique ID by add this function get range. So you are able to see here where I just write this from the reference of our Google Sheet. I just add this function get range from A1 colon A dot get values. So from the first row itself, we have added our unique ID. So that I just refer here. In that row, first row, we just go and add our unique ID, then it will be incremented automatically. So that just I add id.filter of string.length. What we'll do is just find the length of the string and from the reference ID, then apply it and add the number one by one. Very simple. Then our third column is date. I just adding our date by date constructor. If we write just like this new data, then the current date will be added, right? I just add the time zone here. And finally, I just added the format of our date. You can change it for your convenience. I just given DD, date, month, and year. Just add the time and copy the same code for date and paste it and just date change the format only. From the date constructor itself, we have scrapped our time and date, right? Then assign it into C date and C time. So what are the attributes we have created here? Up to this line, we have created our unique ID, date, and time. I just create an empty array, RES. This is for creating our results. Results mean temperature and humidity. So we're able to see here, we have given the data at the end of the URL like 33H64. So I just give the delimiter here as H. So from this H, we have split the data into two parts and send it via URL, right? So here e.parameter is receiving the data from the HTTP GET of Python and assign it into RES. Very simple. Finally, we have added all the attributes to our sheet like this. Just write sheet.append row unique ID, current date, current time. So we have created the array RES. In this array, after delimitation occurs, then the two values 33 and 34 will be assigned as two array indices, right? RES of 0 and RES of 1. Finally, I just return 1. So what happens if this function returns 1, that the row is filled. So what is the need of this function doGet? doGet is actually will help you to get a HTTP GET or POST request from any clients or any apps or web apps or mobile apps or anything, right? Simply open your mobile browser and add the URL I have given to you, and please check whether the data is filled or not. So this happens by means of this doGet function. Finally, I have given the return status intentionally as status colon true, because we just send the URL by browser, but we cannot see the response anymore. So just this function returns the status colon true value as JSON value, and then we can see the response in our browser as status colon true, right? This is for name shaking I have given. Then finally, I just return this JSON, or actually we have given this as JavaScript string value. So we need to stringify this value to JSON, right? We know what is JSON, JavaScript object notation. So I just stringify it. Stringify of what? The RES. The RES is status colon true. Fine. So the definitions of two functions are over. Just name it as get data. So once we save it, I just rewind it. Okay. Once we saved it, we just go and publish the data. Publish the code as web app. So deploy, go to publish tab and click deploy as web app. You'll open this pop-up, then just go to bottom. It asks you who has accessed the app. I just write, click anyone, everyone. And it asks you review permissions. Then go to review permissions. Go to your account and allow it to access the web app we have created. Finally, I deploy it. See here, you're able to see current web app URL. Inside this rectangle, we just copy the URL. This is the URL I have given earlier. Okay. I just click OK. This is the URL what we are using. See, I'm going to paste this on Chrome tab here. Okay. Please listen. At the end of the URL, we need to add query string. Then only we will get the data. So I just parallelly open the Chrome here. At the end of the URL, I just put question mark val equals 33h 66 62 or 63 and type enter. See here the data is filled dynamically. Here we get response as status true. Fine. So our data set is ready. Fine. So what we do is we will add this to our machine learning algorithm, right? I just go and share my Chrome, Google Chrome browser. Please wait. I just close this video. Please wait, I'm back. Now I'm sharing my browser. Here, type Colab. So open our ML model. Fine. Again, I type import request. So what we did is response equals request dot sorry so I just add a variable here data. So we need to create the variable here data. So please follow me. So we have to create two data here, temperature and humidity. Actually, for the name shake, we just add a two integer value and add at the end of the URL. But actually, you just use your Raspberry or Node MCU or any embedded devices and add DHT11 sensor. This sensor will sense the temperature and humidity. Then send the value to Google script. So here we just create the random data like this. we need to add random data. So I just import the random module. So temperature, comma, humidity. I just create a tuple here or tuple here. Temperature and humidity as random dot randint 33 comma 39, then comma random dot randint just like 45 comma 57. So we need to add the data as string, but the random dot randint give you as integer value. So we need to convert the integer to string. So I just write like this: temperature and humidity, then data equals so what is our delimiter? H. Hope it works. So at the end of the URL, we add this data variable. So it highlighting here. Okay. Now I want to run this. Yeah, it's executed. Just see the response. Response 200. Open our Google Sheet parallelly. I just delete everything. Oh, run again. Yes, comes. So what do? We will keep on getting the regular data every second. We just add it inside while or for loop. I just add this code, this one line code inside try block, because at the runtime for any interruption, it will avoid this and run. Keep this as one tab intent. Inside except just write pause. It will take away from you. Sorry, from this code to you. Then above the response, I just add for I in range. I just add 0, 5, 1. Okay. Now we just run this. Okay, intended block is for. Okay, fine. So I have added 3 modules: NumPy, Matplotlib, and Pandas. So we can manipulate our data in the form of our 2 multi-dimensional arrays with the help of NumPy. Then Matplotlib is used to plot or represent your data as graphs. And Pandas will take care of your data as data frames, right? Very simple. Finally, the 3 modules are working fine. Yes. Then we need to add the data set here. So before we need to add this, we just upload the data set. So in case of Google Sheets, we have filled every day our data from the live temperature and humidity. The data is keep on adding on Google Sheets. Then finally, we just add a script. That script will help you to accumulate the data and save it as CSV on Google Sheets or Drive. Then we can get it after the 2 weeks. We can get it the data, get the data from the Google Sheets or Drive from Colab, right? I just add manually here. So it says uploaded files will get deleted when this runtime is recycled, so that we have saved it in separate drive or Google Sheets. So what it says, we just finished or close this tab. After you open this, the data has gone. Now the data is here. I just right click and copy path. So the data set is, I just use the pandas as PD, pandas library as PD dot read underscore CSV, right? So autocomplete will help you to get the functions. Inside that, we just paste our path here. So inside the content directory, our data set is here, right? Just run this. If we want to see the data set, then type data set. Click here. Yes. We are able to see the data set. There are 671 rows and 6 columns. Fine. The same data we have filled in the Google Sheets are here. Fine. I just go and click plus. So what we'll do is we have created our data set. We just extract the future. So what we will go and predict, we'll go and predict the humidity of the living room, right? From the temperature value, so from the temperature row, from the temperature column, with the help of all the data, with the help of the training all the data, we just go and predict the humidity value with the help of this machine learning algorithm. So we just scrap the data from our data sheet as temperature and humidity like this. I just type x equals. So what is the reference of a data set is data set dot I just split the string. So which column we need to get? This fifth column. So x dot iloc colon comma 5 dot values. I just execute this. So fine. We just see it. Yes, the value will be here. For the visibility, I just clear the output. Just grab the y value as data set dot iloc. Yes, it works. Actually, this data x and y are in single dimension. We need to convert this as multi-dimension with the help of reshape function. I just add a new code here and type x equals x dot reshape. Fine. I have given the order. Then y equals y dot reshape. So we have executed successfully. Just see x and y. X. This. Fine. Again, just go and import sklearn model to apply linear regression. Actually, we can build our own linear regression model. That is within 19 to 22 lines. We have to create our. We will be able to create our own linear regression model. No problem. But the time is very less, so I just use this sklearn model. So from sklearn model selection. So what we do is we just import train test split from sklearn model selection. Yes, no syntax error, it works. So we have to split our data as x train, x test, y train, y test. I just type x. Now we are using our train test split module, right? It will be opening here. So train test split of what? Already we have the data as x comma y. So this xy is reshaped x and y. So we can use it directly. Test size I have given 80% for training. So I just testing purpose 20%, like 0.2. Put random status 0. Yes, it works. So we have splitted, this splitting process is over. We have now x train, y train, x test and y test. So we just need to import our linear regression model. So from sklan, dot linear model import linear regression. Fine. Then regressor, we have creating here an instance of linear regression model as regressor. So regressor equals, just type the class name as linear regression. Actually, this is a no argument constructor. This will create an instance of linear regression model as regressor. That's very simple. Just execute this. Yes. No error is there. Then we just type. The next step is we just go and fit our x train and y train by means of our regressor instance. Yeah, it's available here. Regressor dot fit of what? Our x train and comma y train. What happens? Found input variables with inconsistent number of samples. No chance. Okay. I think the column name I have given is wrong. Put this 4 and 3. Again, reshape it. So all the codes are available at instant. Then execute this. No, again. This is right. The model is okay. Just want to see the x train and y train values. Just clear the output. or I think the row is very less. I just add another data set here. So there is some inconsistency between the data. I have another data. Sorry. Fine. Here I just temperature and humidity is fifth, are in fifth and fourth column. Fine, it works. We just go and reshape it. From SQL and model, just import the model and yes. Fine, it works. Then type regressor dot fit. Oh, fine. I think recheck the code. I will recheck the code. Please wait. Okay. It says the type warning in column 8, 25. You have mixed types. Fine, no problem. Just to open the data. That is 0, 1, 2, 3, 4. Fine. It will not give any warning here. And 3, 4. Fine. Then reshape. Actually, we have reshaped it correctly, right? Then XKLAN model, okay. X train, Y train, X test, Y test, fine. Train test split, X comma Y, test size okay, random state okay. Again, I just upload the model. Up to this from SK model, regressor, simply to give regressor. Again, I read the error. Found input variables with inconsistent number of samples 503 168. Fine. I think the data, some data is missing. Input variables, samples. Fine. Okay. Okay, we have to nullify the data, nullify the null data, actually remove the null data with the help of pandas, then only we can give. Okay, fine. Good. So I have make this for you within 2 minutes. Please wait. So are you able to see here? So sorry for delay. Actually, the problem is inconsistency of data. Then just clear it. So the regressor dot fit is executing here. Then the score of the prediction is here 99%. So this is a very good prediction here. Then I just plot this as with the help of matplotlib. So the prediction is like here for the reason of very lowest data. So the graph is like here. So it seems to be very good if we are using large number of data. So if you are having any doubt, please ask me. And shall we wind up?
Yes, sir.
So thanks to all. Thank you.
So thank you, sir. It was a wonderful and effective session. And I sincerely thank you for sharing your knowledge and ideas regarding this topic. So participants, if you have any queries, you can unmute yourself or type your queries in the chat box.
So I'll share the videos and scripts here. You can use it. Thank you. Thanks a lot.
So I hope there is no queries from the participants, and I thank you, sir, for your valuable time for sharing your time with us, and I thank all the participants for making this event a success. You made this event an interactive one. So we'll wind up the session, and we'll meet in the next session. Thank you, all.
Thank you.
speed to delivery to the market. So every team first has to be educated with best practice.
Hello, very good morning. Ma'am, voice testing, can you please ensure like it is audible?
Yes, ma'am, it's audible. So
Okay.
other participants, will you please mute yourself?
ఏమన్నా అక్కడ ఎవరు లేరు ఇప్పుడు.
Ma'am, please confirm whether I can go ahead.
Hello, yes, ma'am.
Can I go ahead, ma'am, with the presentation?
Yes, ma'am.
Is everyone ready? Okay, okay.
Okay.
Okay, hi participants, a very good morning. So happy to meet you all in this short-term training program. I'm Dr. Rishmi.
One second, ma'am. So the
Okay.
session will start officially. So will you please wait for 2 minutes?
Sure, ma'am. Okay.
Okay, ma'am.
Please let me know, okay, when I have to commence.
Okay. So after the introduction, then you will start the session, ma'am. So just 2 minutes, ma'am.
Good morning, all. It's a session 2 of day 3 in this STTP series. So, this session topic will be on profit algorithm and its application, which is going to be presented by the speaker, Dr. T.R. Reshmi ma'am. I thank our institution and our CEO, Sri Sairam sir, for arranging this series. And also, I want to thank AICTE for sponsoring this event. I thank you, the attendees from various institutions across India, for joining this session. Once again, I thank our principal, Dr. K. Paranikumar sir, event coordinator Dr. B. Sridevi ma'am, event co-coordinators Mr. Jay Chandran sir and Mrs. Rajalashmi ma'am for making your presence in the session. So without any delay, let me introduce our speaker of the session, Dr. T.R. Reshmi ma'am. Reshmi ma'am is a scientist in Society for Electronics Transaction and Security, and she has a PhD in Information and Communication Engineering, Anna University, Chennai. She is a certified Cisco Academy instructor and a certified IT infrastructure expert. Moreover, she has given more than 40 plus research papers and journals and books, etc. So without delay, let me call upon Dr. T.R. Reshmi ma'am to take over the session. Please, ma'am.
Thank you for a nice introduction. So it is my pleasure to have these participants for my presentation. So welcome you all. So without a delay, I'm getting into the presentation. So today's discussion would be a session on predictive algorithm, and especially I am focusing on a profit algorithm. That is a Facebook released algorithm in 2017, which is being highly used right now. And very currently, Amazon has appreciated its application in its use in AWS cloud. That is a service that is being provided by Amazon. So let me get into the presentation. So is it visible now?
Yes, ma'am, it is visible.
Okay, I'm going ahead. So as discussed, we would be covering up a predictive algorithm today. So this is the outline of today's presentation. We will be seeing an introduction on time series forecasting, and specifically we would be discussing on profit algorithm and what are the characteristics and features that it has, and what is the installation procedure that it follows. And we will have 2 demos on 2 different applications, and we will conclude the sessions. So probably this is the 3rd day in your training program, and I believe you might have seen a lot about the machine learning algorithms. So what is supervised, what is unsupervised, right? So I think there won't be a big discussion required on this. So forecasting challenges. What is forecasting is you would be predicting a future with the data set what we have today. So we can have an analysis of the current data we have, and we will say what can happen in the future. So based on the predicted value, there can be even a changeover that can be made in the current data sets and can make the future look better and better planned. So that is what is a requirement for a forecasting. So the current scenario, even if there is forecasting algorithms available, there are some challenges. So what would be the challenge? The main 2 challenges that we face is, even if there are automatic forecasting techniques available, they are very brittle. They are not flexible enough based on the requirement of an organization or an application. So it requires a heuristic study every time when it is being used on an application or when it is used for a specific criteria for an organization. So there is a challenge that we face today. Another is, even if there are automatic forecasting, there should be an analyst who can specifically say what should be the forecasting data set that is being required. So these two things are the major challenges we see in all the techniques that is existing. So we would be discussing mainly on time series forecasting. So it is a supervised training application, and we will be making or building a model with a predicted value for a date or a past data as a training data, and then we feed it with a model with a future date so that it produces a future dates forecasted values. So this is how it works. So we know this is how it has been checked with. If we have a data for day 1, day 2, and day 3, we would be able to predict what would happen on day 4. Okay. Similarly, if we have data on day 2, day 3, day 4, we can predict what will happen on day 5. So like this, we can account for n number of days. Okay. So there are many traditional time series models. So what is a problem that we face today? Okay, so here when I discussed about this series of how it happens for n days, I said if we know day 1, day 2, day 3, we can predict day 4, right? So the interval between these days are equal, 1 days. So if there is a change in the time interval in this data, it is not that easy to predict the traditional time series model. Okay, so if you have 2 days break in between, and if you're trying to predict the 4th or 5th day, the prediction will not be that accurate. Okay, so that is a problem we have. And another is, sorry, there is a admit request that is coming up always. So can anyone help me out? I think the organization, the organizer can help me out. Okay, I'm just getting into it again. So the other problem it faces, if there are days with NA, for example, in the previous slides, we have seen, right? We have day 1, day 2, day 3 followed with day 4. Imagine you have day 4 and day 5, which is a holiday. Okay, so even if there is a data that is retrieved from a holiday day 5, it will not be used or can be used to predict the value that we have for the day 6. Okay, so that is actually accounted as NA. So with that data, actually, it is going to make the prediction little bit weak. So if we have something that is NA applied, if there is a helping hand which can make the NA not to be allowed, that can help you out in a prediction, but that is not actually possible with the traditional time series model. Okay, and seasonality, like you want it to be accounted for a week only, you want it to be accounted for many years, like 4 or 5. These are not handled in current time series model. Okay, and even the parameter tuning by experts is necessary. The automatic prediction, it is not that easy with the traditional model. So the currently evolved and the most forecasting algorithm we have is actually Prophet. This is an open source algorithm that is given by Facebook, and you have all your source codes, everything in GitHub. So they are given it as a open source for all the domains. And you don't have to be an expert to use this algorithm. Okay, so you can say, like, even if you are an amateur in this field, you can try this tool very easily. Okay, that is the benefit of using the Prophet algorithm. So what are the characteristics that we have in the Prophet algorithm? So we said these are the issues that we have in traditional, right? All these issues are overcome with the help of the Prophet. So we have many seasonality variants that is possible. You can make a data set for hour, you can make data set for daily, weekly, and these observations even for months, everything that historical data can be made, and with that you can make an accurate prediction. Okay, and so these seasonality is adding up more accuracy in your prediction. And even the NA type of days, I said holidays are not accounted in your traditional ones, but these are accounted in profit. Okay, so this irregular intervals, even if it is reflected in the data set, that will not be making trouble in your prediction, and that works well with profit. So NA is not applicable. That type of a data set is even evaluated with the help of your profit. Okay, so many outliers. What is outlier? There is a missing of the observation. Probably even if there are data that is being generated, for some instance may not be like you may be having a lot of data which would be overflowing your buffer, and that can not be like saved in your server. So there may be many reasons which may be practically happening. So in those cases also, these are like allowed in profit, and it can give accurate results with the other data that it has. Okay, and even if there are like many instances, there can be a trend change suddenly, which are said to be like not exactly within the min max ranges, even that is being accounted. You can have non-linear growth curves in So this is a forecasting procedure we have in Profit. So we have a modeling, we have a forecast evaluation, we have a surface problem, and finally we have a visually inspect forecast. So, hello. I think there is some disturbance. Participants, I request you all to mute so that I can give a better presentation. Thank you. So these are the 4 phases that we see in forecasting procedure of profit. Okay. So with the profit, when you compare your profit with the other forecasting packages, there are 2 things that is said to be like highlighted when you use profit. Okay, this is more straightforward when you compare it with the other forecasting techniques, because whenever you have a forecasting package with profit, it will try to evaluate many techniques with your data set. Like it will try to employ ARIMA, exponential, many techniques, and it will check like which technique would be best for your algorithm, and that would be chosen. Okay, so a wrong model prediction will not happen with profit. So that is a benefit that we have, and it is highly customizable, and it can be used even by a non-expert. So these are the 2 benefits that you have when you compare profit with other forecasting packages. So these are some of the components that you have in your profit. Overall growth trend would be there, yearly seasonality, weekly seasonality, holiday effects. These are some of the components that it has. So when you have a demo, you will have a better understanding. So with the data set, you can see these are the data set values that it has, and it has been plotted. This is how the trend would be. So when you see it, when you try to plot it as a line curves, this is how it would look like. So when you incorporate an yearly seasonality into this data set, okay, so the data set, the blue color, dark blue colors actually shows the line curves of the data set, and the cyan color or the light green mixed blue color, that is actually the line curves that shows the yearly seasonality. Okay, so we have a problem in the screen sharing also, so all these are not clearly visible, I hope so. But anyway, I think it would be vague, but for a better understanding, I would be sharing the presentations also. So this you can see, so these 2 are being mixed up. So when you combine it, you can see this is how your trend goes on. And when you do an analysis, you can see the orange color one is the analyzed or sorry, the forecasted value that it has given with the data set. So you can see it closely resemble with what the data actually reflects. So I said there is one more component called weekly seasonality, right? So this is actually the weekly seasonality data set that is being included. And you can see like by including it, it would be giving a very fluctuating line curves, right? Which actually shows the data in a week-wise manner. Earlier, it was showing us yearly. So that is why it was showing a vague data with a minimal curves. But here you can see there are like many fluctuations in the data, which is the weekly data sets. Okay. So when you try to embed your weekly seasonality into your data set, you can see the prediction goes still more precise. And you can see the orange color ones are the predicted values, okay, with the data set that you have, which is a combination of trend, yearly and weekly. Okay. So when you do this, you will have a mix up. And finally, the last component of profit, that is a holiday effect when you try to include. What is holiday effect is when you know which are the days that you have as a holiday and you are trying to check whether this holiday has an influence on the data set. Okay. So in some application you can have. So when you are discussing about an application or a demo, we will see how that works. Okay. So when you try to give a holiday effect seasonality to this data set, you can see it still varies, and the prediction that it made with all the four combined, you can see it is giving a very accurate prediction. And this actually the orange color ones alone without the blue color, that is actually forecasting the future. Okay. So till the blue line that we have, it is actually the real data it has and the predicted data. Okay, so after training and testing, this is actually the data that it has generated for the future prediction. Okay, so this together combination of trend, yearly, weekly, and combined with holiday effects would give you an accurate result for some applications. So these are the benefits of the profit approach. So uneven time interval can even be taken up for the data. It is not an issue, and days with any is not a problem. So this I've already discussed. I'm just briefing it again. So seasonality with multiple periods can also be handled, and it works with a default setting. But if you want parameters to be exactly chosen, even if you are not an expert, you can make it with an ease. So these are the installation procedure. So being a scientist and now currently I'm working from home, I have some government run projects. So I'm not in a position to show you the installation in my system. So I have done it. So I believe this would be very easy and it will not take much troubleshooting or much of your time. So the process is very simple. You can do it in 5 minutes. Now we'll see a demo session, okay, which is already being done, and those slides are being shared, but it gives you a proper understanding of how the profit works. Okay, so this is a sales data set that is seen. So this is shown as an analytical view. It has around like 1 or 2 fields, and these columns says like order date, ship mode, customer ID, customer number, segment, sales, quantity, etc., etc. So this is a visualization of the line chart we have with the data set. So this is how your profit web page would look like, tool web page would look like. So when I try to open the specific data that is shown there is a sales data of a particular organization. This would be the field that it would be showing up. Whatever we have seen in the previous slide is shown here. So in profit, it would be shown up like this. It has an order date, ship mode, customer ID, what has been discussed as different columns, right? So that would be shown here. And you can see we have chosen order date as another way. I want to plot hello, is it audible now? Can you please confirm, is it audible now?
Yes, ma'am.
Oh, okay, sorry. Okay. Is the screen visible, ma'am?
No, ma'am.
Okay, 1 minute.
Yes, visible, ma'am.
Okay, ma'am, thank you. So we were discussing on a data set, and we said we would be taking up two data specifically. One would be the order date and another would be sales. Okay. So we are trying to see what are the orders that the number of orders that has been received in a specific date. Okay. And we are trying to evaluate the trend of how a forecasted value can be predicted. So with these two fields, we are trying to make a prediction. Okay. So you can see I am trying to make a time series forecasting. Okay. So with the data, you can see I have chosen order date in x-axis, and in y-axis, I am trying to take sales. Okay. These are the two data specifically we are taken to predict. So when you try to plot it as a line graph, this is how it would be showing up. Okay, so you can see at a specific place, this is the order date and this is the sales, okay, sales value that we have. So we are trying to choose time series forecasting, right? So we will choose when the type time series forecasting, and in x-axis order date and in y-axis you will choose sales, okay? So when you do an analytics with this and when you try to run it, you can see that with the data set that is showing up as blue, that is actually the plotted one that is in the line form. And this orange one is analyzed and is being shown as a trend that is being shown up. Okay. So this is the analytics that we make. Now, you are trying to change the analytics properties, okay? Actually, this has been plotted for a year, okay? Which would be showing us like 10 weeks, okay? You want it to be shown for 52 weeks. Now, you can change the default setting of the time period from 10 to 52, okay? And then you try to apply it. And when you try to apply it, you can see as shown in very like precise form for 52 weeks. Okay, so this is how it has been tested. And when you want the trend to be seen, you can see there is a button called trend. So this will show you the trend in year, weekly, date wise. So here you can see this is a trend set for the data that we have. So yearly it would be looking like this. It goes like this. If it is date wise, it would be showing up the trend in this way. Okay. So if you want to detailedly see a specific piece data alone, you would select it and you will try to see it in a very precise way. Okay. So this is a short periods trend set, which is finally being given. So if you want to analyze for a specific date, that even is possible with the data. Okay. Now, I want this to be, I have two fields now. I have chosen order date and the sales values, right? Now I want to see the market that has happened in different areas like Europe, Africa. So to see that, I have seen there is a data field which was showing up the specific values that is in different regions. So to repeat, I would be choosing something called a market. Okay, you can see that that is there in the data set that is being given to us. So I choose it. This is the market data set, and it was showing 5 different regions. And now I try to run the same data set with this. Okay. With the two fields like your order date, sales, and with the market. Now, this is the 5 regions, 5 market regions trending values. Okay. So this is how it looks like. And if you want to scale it to better see the values of x-axis and y-axis, you have an option here. You can change this by changing the x and y-axis. This can better presentation in x and y value. So again, if you want to see the yearly trend, weekly trend, yes, this is possible. Okay. And if you want this to be exported to some other forms like CSV file or a DF file, this is also possible. So after doing a forecast trend, you can keep this to be exported into some other form. Okay. So to better make you to understand, I'll say like you have two different data. One was used for a training and one was used for a testing, right? So we have the one that is shown as blue, which was actually showing up the real values, and the orange was actually the forecasted value, right? So it was with the data set what we have, it was showing almost a similar value for the testing, but it was showing a little vague values or a little not close values for the forecasted value, right? So with the testing, so you can see this is the trend it was showing. And so when you try to summarize the model, you can see whether the forecasted value is accurate or not with 4 of this parameter. I know when I show you with this slide, it won't be that understandable, but these are the 4 metrics with which we evaluate whether our forecasting is correct or not. So these are the 4 metrics we have. MAE, that is a mean absolute error, which is the absolute difference between the actual value and the forecasted value. And the root mean square error, which is the root of the mean of squares, okay? That is the difference between the actual values and forecasted values. So these two are regularly used when you account for almost similar type of market values. If you see this slide, okay? You can see the Africa region, which is showing very little sales, right? But when you compare Europe and also California, US California, okay, this was showing a very good sales with the data sets what we have, right? So when you account 2 of the metric like MAE and RSME for these 2 data sets, it would be showing up a very good results, okay, which shows a very good accuracy for these 2 ones. But when we account for this one with others, okay, we better would be choosing MAPE or MASE, okay. MAPE is mean absolute percentage error, the mean of absolute difference in percentage of actual values, okay. Or you will be using mean absolute scale error. Here we would be running 2 models and then we would be trying to evaluate this. So you would be dividing the MAE value, that is this one, of the forecasting model, that what we have done with the MAE, of a name forecasting model, which is another forecasting model, and then we'll try to evaluate it. Okay. So this is for a better understanding of what is root mean square error and how it is being evaluated. So this would give you what is the error or the metric. And this is a mean absolute error. Okay. So this is actually the difference, just the difference. But earlier RSME was the root of the square difference. Okay. So this is a percentage error where you will take the actual values, then you calculate the ratio. And even if it is a negative one, we will make it to be positive as it is absolute, and then we will find it. So to check or to compare the markets, okay, we can repeat it and then build multiple forecasting models. Here you can change it and you can try it. But with all the 4 metrics, you can try it. So if you want your testing and training data to be exported in 2 different files, yes, you can do it. You can change the uncertainty interval to true or false, and then you can make whether you have to export the data only that is a testing data or the training data. So this is how it works. So you can see MAE for Europe, California, it was showing good values, right? But you can see Africa is the least, correct? But when you account for MAPE, you can see Africa comes to be the best, right? And others are less. I mean to say, if the values are very less, when you comparatively see with the other data of the other data sets of other markets, you will try to make MAPE to be the metric to evaluate this. Okay, so there is one of the scenario that we have seen. We are trying to check what is the number of order that they have received in a particular date, and we are trying to check the seasonality based on weekly, yearly and holiday effects, and then we will see how it works for future, and you will predict what would be the sales that can happen in Europe, what can be in Asia. So probably, as I said, Amazon might have used this data and have well predicted what would be their business in the next coming up years. Okay, so that is how it works. Now we'll see another scenario where we will study really what is the effect of a holiday. Okay, so you can see this is the data set that we have, which has only 2 fields. Earlier there were around like many columns which were showing different values of for different specific titles, but we have only 2 here. One is date and another is the number of visits that happens to a conference web page. Okay, so Apple Worldwide Developers Conference page was there, and the number of hits or the number of visits to the web page is actually being accounted to evaluate these values in this column. Okay, so this is the day and this is the number of visits to a web page. Okay, so here again the same process, we are trying to make an x-axis and y-axis. So we will choose the date and we will also choose the value for value column to be the visits of the web page. So this is being plotted, and you can see you have chosen time series forecasting, and now see this is the prediction that is being met, and this is the trend that we have. Okay, so with the value that is being plotted, we understand it has made a trend set, and this is what is being predicted. Okay, again, so when you do an analytics, this is how it looks like. Now, actually, I want this prediction to be done in more accurate way, where I want the 4th component, holiday effect, to be included. Okay, so for this, a special data set is being accounted here, and we try to merge this data with the already existing data. Okay, so I have a data of holidays of that year, and I account for those datas here in this data set. Okay, so it says like the day, and it says like whether it is a holiday or whether it is not a holiday, that is being given here. Okay, now I'm trying to merge this data with the already existing data which we used for a forecasting. Okay, so which already had 2 fields, right? Date and the number of visits. Now I am trying to join a new column here to the existing data sets. So you have an option called join, and in that add column. Okay, so you try to add one more data into it. Here you can see this is the name of the frame that you are trying to join. That was already shown in the previous slide. Okay, you say the format for that is actually date, and the target column is DS. Okay, and you want that to be joined as left, or you have a different joining option, whether left, right, etc. But actually, when you give full join only, you would be able to give a future prediction. Okay, that means it would be getting adapted to predict to future. So you will opt full join to be the option for this. Okay, so when you try to merge this, you can see you have 3 columns now. Yes, this has been merged, and you have a date and the number of visits of the web page, which was already there in the data sets, and a newly merged column, that is a holiday that is being added. Okay, so there they had the data of the days which was accounted as holiday, right? So those days were marked as holidays and other was accounted as NA. Okay, so that is actually was not possible in a traditional forecasting algorithm, but this is possible here, right? So we have added it, and now you can see after adding it, and when you try to make this repeat with the help of this holiday column included, and by changing the pin with a new data set, okay, you can see by adding it, yes, you have a better predicted value here. Okay, so earlier when you compare it, you can see, sorry, okay, so this was actually without including a holiday effect. Now after including the holiday effect, you can see it has very precisely predicted this would what be happened, or this would happen in future. Okay, so this is the effect of holiday in this data. So earlier I said the prediction was only for 52 weeks, right? But here we said your account is with date, date only, day. You can see here, day, right? So you will make it to be 365 to predict the future, which says like for 1 year what will happen, and you want day-wise data to be accounted. Okay, so when you do this, you can see a day-wise prediction is being done, and this is being plotted here. Okay, so this precisely will show you how the holiday effect has given a prediction for the future. So this is all about the profit algorithm. So to conclude with, I said even a non-linear trend that fits with yearly, weekly, daily seasonality, all these pluses are there in the procedures, and this can be well done with the profit algorithm. And all these seasonality effect can strongly build a preciseness in your prediction. And even if there is a missing data or larger outliers, it is well handled with the profit algorithm. So based on the application what we have, for example, I want to predict the ice cream business that is happening, okay, and I want to stock it accordingly for a future. So what I do, I will check what is the seasonality that it has yearly. I know it will not have a good sales during rainy season. It will not have good sales when it is like a highly hectic days in a workplace. For example, an year end or highly business running days. Those days people will not have a leisure, so probably the ice cream sales may go down. And during summer it would be run very well, and in some cases like in holidays most of them will have a fund, so the sales would be more. So these impacts would be there on the business. Okay, so those type of a prediction, if you have a clear data set for a historical data for like 5 to 6 years with a clear values, you can have a good prediction with a profit algorithm. Okay, so based on the application what we have, then only we can choose whether to use like a profit algorithm for the prediction. So another example is like you have a 5G network, okay, and 5G have something called a self-healing, where you have like devices which would go for a reboot or which would have like a failure, and 5G network by itself sensing the network going down or the device going down will do a self-healing, right? So profit algorithm can be used there to check what is the normal network trend that happens in an area in a particular day or even in an hourly basis. If it is a peak office time, yes, surely this would be the network traffic running. And if it is trying to lower down gradually to understand there is a problem in the network due to a device failure, network failure or reboot, so it auto heals it and try to do a better service so that it can be self-healed quickly or easily. Okay, so the SLA concept that the provider gives can be better be sticked on without having any loss. So that is how it works in some type of an application, and even in some security analysis. If, for example, there are some malwares which regularly would do denial of service, right? So if we know what is the predicted value that a system can or server can generate to hit any of the network, okay? And if it is going more than what is being predicted, you can understand it is being affected with a malware, or it is trying to host a malware with which it is launching an attack, and you can try to avoid it. Okay, so these are some of the applications that we regularly see and can be used to analyze with a profit algorithm. So predictive analysis is a very good field. So based on the algorithm that we choose and based on the application for which it is being used, it can give you a precise results. So these are some of the references that is being used. Actually, I tried to make it up as an installation and a demo using the tool itself, but that was not possible because of restrictions we have in our systems. So anyway, I think these slides which I share, and even the organizer can help out in sharing this with the participants. This can give you a better understanding of the algorithm, and probably I think everyone would try it and use it. And the methodology that is being used is very simple, so any non-expert person who is just entering into this field can try it. Okay, so thank you for the opportunity, and it's a great pleasure in spending time and giving a very small session. So probably meet you all in later on session. Thank you for the opportunity. Thanks a lot. Hello, ma'am. Is it audible now?
Yes, audible, ma'am.
Okay, ma'am. I'm winding up my session, ma'am. It was a short session, and as planned, it couldn't be given as a demo. So probably I think the slides can be shared, which can be given to the participants for a better understanding. So I'll just share it with the organizer who have given me the login credentials. So thank you for the opportunity, and I thank all the participants for the patience listening. Thanks a lot.
Thank you, ma'am. It was a wonderful session, but too short, ma'am.
Yes. Due to the restrictions in my sides of the system and all, I couldn't make it up as a demonstration with the tool itself. That's why I have given it in slides. So probably, I think when you try the tool, this would help you out. So thank you all. Thanks a lot.
Thank you, ma'am. I thank all the participants and speaker for giving such an extraordinary session. Hope we shall see in the next session. Thank you all.
Thank you. Thanks a lot.
So attendees, we do have a small information. The next session will start by 2 o'clock. I repeat, next session will start by 2 p.m. sharply. So do attend that session also to get your e-certificates.
Hello, Joshan sir. Good afternoon.
Hello, sir. Can you hear me?
Hello, sir.
Yeah. Good morning.
Yes, sir.
Yeah, good morning.
Good morning, sir. Sir, voice is clear, sir.
Okay. Okay.
Sir, can you share your PPT, sir?
Yeah.
We will check it now.
My PPT is visible, sir.
Yes, sir. Visible, sir.
Yeah.
It is visible.
Yeah.
Sir, we will wait for up to 2:05, sir. Then we will start the session.
No problem, sir. I'll wait. I'll wait.
Okay, sir. Okay.
A very warm good afternoon to one and all gathered here. I hope everyone's day is good. So, with that good day vibe, let us start our day 3 STTP series of Vision Intelligence using Artificial Learning Phase 2. I thank all the participants for their continuous support and participation in this event. I thank our Honorable CEO, Sri Sai Prakash Liyamuthu sir, for arranging this event. And also, I thank AICTE for sponsoring this event. I thank our respectable principal, Dr. K. Palanikumar sir, for his utmost support in organizing the event. And I thank our coordinator, Dr. B. Sridevi ma'am, Department of CSC, and our co-coordinator, Jayachandran sir and Rajalakshmi ma'am. And I welcome all the participants who have allotted their precious time for this event. We have eminent speakers from various institutions who have been gathered here to share their views and knowledge about the topic in this session. So here we have Dr. J. Joshan Athanasius, our session speaker. He has done his PhD from Manna University, and he is currently working as an assistant professor in the Department of Artificial Intelligence and Data Science in Savita Engineering College, Chennai. His main research interests include artificial intelligence, image processing, data mining, and many more. He is currently working on segmentation and classification, anomaly detection, traffic surveillance, crowd behavior, object detection, and tracking. He is the editor for the Journal of Artificial Intelligence Evolution, Universal Whisper Publisher. He is a reviewer for reputed journals indexed in Scopus and SCIE. So I welcome you, sir.
Thank you, ma'am. Hello, ma'am. Shall I start the session?
Yes, sir. You can start.
Yeah. Good afternoon, everyone present here. Thank you, ma'am, for giving me a nice introduction about me. And today's topic is about vision intelligence using artificial intelligence. So, as this topic is concerned, nowadays the real computer or a simple machine is trying to compete with the human to show their performance even better than the human. So there are some set of applications in which these techniques are used, that is machine learning techniques are used, so that the machines are trained in such a way that it can try to overcome or trying to overcome the human in all technical aspects. So this session is about uh, the brief introduction about that. This is what I was trying to say, that vision intelligence using artificial learning. And since it is about machine based applications or machine based technique, and what is machine learning and what technique or what methodology that machine uses to make it perform or to show the intelligence. So a set of computer program to learn the experience with some given task, so that based upon the task some performance will be taken, and based upon the performance and the improvement based upon the performance, the machine will get improvised with some experience. So it's nothing but making a child to understand apple image by frequently showing that image to the baby, so that it can easily understand. The same way the machine will do. We will give some set of experience of some task. With that task of predicting the performance, and we'll be improving that performance based upon the performance of the task. And so let's begin with the introduction of how the basically the image is. So the image here shown was a 2x2 20 x 20 an image with vertical and horizontal direction. So an image is nothing but a 2D representation of xy coordinate of each point will be taken as a pixel, and based upon the scenario or based upon the representation the pixel value will get changed. But obviously the representation of 20 x 20 image will be shown or will be taken by the machine will be in zeros and ones. So the color value or the grayscale representation of that particular image was shown in the right side of the image. And so as I told, the pixel is a building block of that image, which has a combination of red, green and blue channel. So each, if you take any image, or if you capture any image from your camera, that image will be have the combination of RGB, but we will be noticing the color variations of particular image, but the representation of that whole image will be in a set of pixels, and each pixel will have the representation of RGB channel. So I'll show you the good example in Photoshop. I think everyone have used this Photoshop. So if I have taken a single image, and if I check the color background or color representation of the particular image, if you see here they have been HSB, LAB, RGB, CMYK, or some values are shown here. So if you take this three values, there is RGB representation of any pixel, any image. So if I little zoom into this image, then you will find a rectangular blob box that is nothing but each pixel. So if I click onto any one of the pixel here, you will see the variation of RGB getting changed. Can you able to see this? Yeah, I think everyone can able to follow me. So that each pixel is the representation of RGB value. So but if you see as a whole image, it will be having different color variations, but all these variations will be in the range of RGB combination with the range of 0 to 255. So this is the easiest way of representing or understanding the image. So if you take any image enhancement app, if you take B612 app or any pre-process or processing app, will be done with these combinations. So if you want to crop the image, or if you want to do any enhancement, or if you want to do any brightness or reduce the contrast, or I need only the red channel of the image, these everything can be done in Python based upon some set of syntax. So the backend of this Photoshop maybe work on Python, but the syntax of representation on in all the applications will be same. And if I go here to image and image size, I can see the total width and height of the image. So height will be of 600 pixels, and sorry, width will be 600 pixels, and height will be about 399. So the number of pixels will be in the value of 600 cross 399. So that will be the number of pixel size, and each pixel will have the variation combination of RGB. So this is the very basic of how the image will be, and how the image are represented, and how the image are visualized. So let's go back to the presentation. So this is what I'm trying to say. Each pixel will be the building block of particular image, and it has 3 channels RGB. So if you go with the grayscale image, why we are going with the grayscale? And the first and foremost thing that we are going for grayscale is to reduce the computational complexity, because instead of processing each pixel with RGB value, I can go with a single value of grayscale, which will be range from 0 to 255, and each pixel will hold the value, so that it computationally will reduce the what technique or what methodology we are trying to impose. And then we'll get back to the machine learning part. And here if you see, the machine learning was portrayed on how the brain visualize a newly visible object. So if think that we are seeing the apple by the very first time, and we don't notice that this can be an apple, unless otherwise someone will tell that this should be an apple. So in that case, we will be keep on seeing an apple. Our mind will come into a representation if it is a red color, if it is an oval shape, or if it has some center part in the middle, it can be an apple. The same way, machine will takes the feature value of what I have said now, based upon some set of images. Then based upon the feature value, it will be trained itself to learn this set of informations will be taken, so that this will be represented as an apple. So how brain and machine learns, how the brain process the given image, and how they group them. Here the grouping concept comes, because if we have too many variations of fruits, or too many types of fruits, how we will group them based upon some logical representation of their appearance, or by the names, or by the texture, by the color, or different set of values. So how we group them? So here the learning comes by brain process the given image by keep on seeing them. So that is the learning part of human brain. So that if we take into machine, by giving an input, the machine will take some kind of values that is called feature values, so that it can be learned itself to make the representation. And how it classify, and we take by taking some set of image, then finding the closest relationship between all the objects, and we will be classifying them. The same way the machine will classify or to segregate based upon the closest group. So if we take machine learning is nothing but writing a program with some methodology and classification will be taken as a machine learning. And why machine learning? Since we have adapted themselves for the users, and we discover new knowledge from the data set, or it, as I told, it is trying to mimic the human with some intelligence. So if you see these three images, I don't want to give much information about these images, because we would have seen this movie past some 3 to 7 years before. That is nothing but the Indian movie, which is fully based upon AI, computer vision, and image processing and everything. So we will be seeing for each by each step of how this movie was developed. So when you notice that movie, in a very first scene, that Chitty will be given some set of data by the Rajinikanth, so that it will read it automatically based upon the information. Then he will, or that Rajini will ask the Chitty to perform, so that whether it is performing well. So based upon the performance, the task will be improved and the accuracy will be maintained. So this is I was trying to say. And why we are going with ML? Since we have more number of data in the internet, and to increases the computational power, and also for to support for the industry. So in case of industry, instead of performing with the 10 people, if I hold that perform that work by a single machine, I can reduce the cost effective also, and also like performance will be more. So and I like to add the little part of computer vision, because here, as a name says, how the computer visualize the scene. So if you take any hardware representation or any sensor based representation, this computer try to interrupt the visual world to make it understand. So this is the part of the machine learning. And I don't know how many of them were aware of this Venn diagram, that the whole deep learning will be coming under the part of machine learning, and the whole machine learning will be under the part of AI. And so as I told, as AI part, the program that can sense, act, and adapt. So it can act to the environment and will make them adapt based upon the performance or based upon the environment. And machine learning here will improve that based upon the number of data or over time. So if you see this image, one second please. So if you see this image, each different variation of apple for shown here. The first one is red color apple, a second one is apple logo, and the third one is yellow apple. So each one will have different set of feature values. So one, if you take red apple, color will be red, the type will be the fruit, and it will be in a shape of some oval shape. And in case of logo apple company, that will be a sky blue color, that should be a logo, and it has some shape. The same will be taken for the green apple, yellow apple. So in this way, they were different variation for a single apple, and our system or our robo or our sensor will be in a position to understand, to differentiate them very easily. And And in case of machine learning, this will be categorized into 4 parts: supervised, unsupervised, semi-supervised, and reinforcement learning. So what is supervised? So everyone might have some knowledge about supervised, but in technical point of view or real-time point of view, I can say is the supervised learning will be like a good example is teacher taking the class and students are listening. So there will be some input from the teacher. That input will be taken by the students so that they are very clear about that particular methodology. The same way, we have to teach, we have to represent the some set of features. If we have this set of features, this is an object, so that representation we have to deliver to the machine. So in that way, if you do, that will be coming under the concept of supervised learning. In unsupervised learning, will be a good example, like I'm having one sack full of fruits of different type, then I'm asking my kid to segregate the fruits based upon the type. Even my child won't have the idea of what the name of the fruit, but it will differentiate based upon the appearance and textures and color. So if you take that scenario, will be a good example for unsupervised learning. So if the semi-supervised learning is a part of both supervised and unsupervised, we'll have some data for labeled data, and we don't have the rest of the data will be unlabeled, and based upon the labeled data, that unlabeled data will be labeled. I think you can able to understand. Semi-supervised, the combination of both supervised and unsupervised. So the training will be done based upon supervised data, and the testing or the training will be adapted with the set of unlabeled data to make the performance effectively. And if we see reinforcement learning, good example will be this will be adapted based upon the environment. So if we take a dolphin show or a monkey show in the roadside, they will perform based upon the environment. Okay, so that will be the good example for reinforcement learning. And the main the supervised learning will be made with a flowchart of this. We'll have some set of data, then the training features will be obtained. With that features, with the training label as an input, the classifier will train and a classifier will be created. Once it has been created, that classifier will be taken as an input for the test image to compare to make the prediction. And this is a good example I can say. If you see here, I have 6 columns of values and 1 label column. So the label column is a key factor in supervised learning, where the label for each row will be given. So if I have this set of values, and this may be identified as cat, this may be identified as dog. So here I have 2 class of variation by label representation. So as I told, unsupervised learning, I have a sack of fruit and I'm trying to make the person to segregate the fruits based upon the closest relationship. So here comes the concept of unsupervised. This won't have that much knowledge to make the segregation. That way the machine will perform. And so this is the flowchart of how the machine learning of unsupervised based learning was done. So input data, some feature value, then the machine learning algorithm will be used to obtain or to create some labels, because we don't have labels as like supervised learning. Once the label was attained by the unsupervised learning technique, that will be taken as an input. Then the same test data and feature vector from the test data are obtained, and that feature vector will be combined with the labeled acquired from the unsupervised learning, and the prediction of how the cluster ID or here the cluster ID is nothing but in what group that particular test data will be closely associated, or likelihood, how likely that particular test data was represented by any one of the group. And in case of semi-supervised, if you see here, the same data was used, but some data are labeled and some data are unlabeled. So based upon the labeled data, the training will be done. And if you give an unlabeled data for a testing, that will identify it and will be close to which data or which label the particular test data is closely associated. So if you take reinforcement learning, the dolphin show will be the good example, because whenever the dolphin performed well, it will be rewarded by giving a fish. Have you noticed that? I don't know how many of them have noticed that. If you are not noticed, please go to YouTube and check it out. So that will be given some set of reward based upon the performance. So if it doesn't perform well, that will be given some uh, okay, like a performance of how you can do or you can be done. And so the agent here is nothing but the object which performing an action. So if you take dolphin show, the dolphin show is an agent, and the environment is here is the viewers and the person who's leading the dolphin. So if we take this reinforcement learning in machine learning point of view, the robo or a sensor will be an agent, and it will perform some action to the environment, and the reward based upon the environment, that will be improved, that performance will be improved based upon the reward. So, and another example I can say is, if you are putting a rat suddenly into a new environment of a room, it will run here and there to make it to identify where will be the flexible path to go out. So if you come after 10 days or 15 days, if you open the door, that rat will exactly get into the area or get into the some position in the room where that it can easily hide or it easily escape from the activity. The same way, if you see here, based here the learning was done by the rat to make it performance. So the action was implemented in the environment, and the observation will be updated based upon some rewards. And every technology will have some challenges, and machine learning is also one of that, because we are performing this in the outdoor environment. We are performing because each environment will be different for each number of times and each number of days. So some challenges which we will be seeing here is, the left image shows the background, that is bark of the tree, and the foreground, that is the butterfly, are not visible, so that it is very difficult to identify the butterfly. So let's take an example that we are creating a robot, like since we are in joined together in a meeting, so we are creating a robot that to identify the butterfly in a farm. But if the butterfly that is present in the farm in the green color, will our machine will be in a position to identify. So that is the background and foreground will be merging, trying to merge each other, and this will be little more difficult for the machine to identify. And if you see the right side image, that is dog which is holding a wood. So if suppose the information that you are needed, if it is present in the region of the wood where the mouth is, will be our machine will be in a position to identify. So that is one of the biggest question, and how we can retrieve the data. And second one is viewpoint. And so we see this, each object will be visible in a different viewpoint into a different object. So we have to train for each object in a different viewpoint, so that our system or a machine will be in a position to identify. And the second one is scale invariance. So this a good example is, if you see a very long lost vehicle coming some 100 to 200 meter long, will be seen as a small object. So when it's coming nearer, the size of an object will be keep on increasing. So this is one of the biggest challenge in machine learning point of view. And the fourth one is occlusion, that is overlapping or some part of information are hidden from the scene. So if I see the left side image, the whole region, a whole object of vehicle are easily, whole region of dog is easily available. But if you see the right side image, some part of the region of dog head was covered. So if I do any animal based classification, if I give the right side image as a test data, my system, or sorry, our system will be in a position to identify that, correctly identify them as a dog. And the fifth one is illusion. So some part of information was totally hidden due to the brightness and contrast of the scene. So the feature value that we will be obtaining by the left side image is more than the right side image. And the intra-class variation, if you take a chair-based classification, if you are having a 10 classes, 10 chair, each chair, 10 company of chairs, and each company will have n number of intra variations. So we should be in a position to train all the possible, all the flexible number of data, so that to make our system very effective. And these are the basics of how the machine learning types and what are the challenges. And now we will be getting into the application point of view of image processing and machine based stuff. And the list of applications we will be seeing here is image segmentation and classification, vehicle detection and tracking, face detection and recognition, pattern recognition, and video surveillance based application, and robotic vision based applications. And in case of object classification, each object will appears in the real time, and there will be multiple binary patterns for each scale, as well as the different classifiers will be there for real time. And another type is online feature selection method, which we have multiple class object classification with limited accuracy. And the classification with high and low resolution of an image will be coming into the classification of multiple levels of classification. So these are the main three types of classification. And in case of image segmentation, segmenting the same class, that is, we'll be having many number of objects of different types of fruits you can take. So how I will be in a position to identify only the fruits in the given image. That will be the one point. And instant segmentation, if you see here, plays a vital role, but because this instant segmentation is the recent research hot topic, now it was going, and but this will be taken from the scenario of object recognition, thematic segmentation, object detection, and the updated version is instant segmentation. So if we see the image recognition, if we see there, I can see 4 animals of 2 types, dog and sheep. So so the probability of sheep is 0.6. Since it was shown in a 0.6, we can take the 60%, and dog has a probability of 0.3, that is 30%. And they are one of the probability of cat as 1% and horse as 0%. So maybe the dog may be identified as a dog by the mission, by the cat by the mission. So if you take semantic segmentation, here the region of object alone has been taken and segregated. So that based upon that semantic region, this informations will be identified. So if we take object detection, here the object detection was done by putting a bounding box for all the images, and each bounding box was shown with a different variations or different color, so that they are 4 objects in the image. So if we take instant segmentation, there each sheep was segregated and it was shown in a single bounding box. So the semantic segmentation and instant segmentation will make the much difference, where in semantic, whole sheep was shown as a single object, single identification mark. But in case of instant segmentation, each object of same sheep was shown with the different segmentation colors. So this is what we need, because say for example, uh, to identify the health of the sheep. If you are trained the system to know how the sheeps are really working on it. So if in that case, if I perform semantic segmentation for for a 100 plus number of sheep, I can see only a whole blob of capturing the single whole sheep. But in case of instant segmentation, each sheep will be taken as a single object, and performance of each object will be taken and segregated. And the workflow for classification was done here. So I have taken a single image, then from that image each blob based deep learning approach was used. Here the convolution with max pooling layer was used. Once that information was taken, based upon the fully connected layer, the probability of the given input image of any class will be taken. So I have taken a test image of a bird, and the probability of each object of the trained label was taken, and the probability of the bird will be obviously very high, so that that range, the highest value will be taken as the classified image. And here non-maximum suppression plays a vital role in object segmentation and object detection. So what it will perform actually, if this will perform, or this will have multiple bounding boxes over the images on different scales. For example, if we take an image of size 300 cross 300, there it will identify the region of the vehicle, then it will compress into 200 cross 200, then they will apply the bounding box. In that way it will do for several or n number of resized image, then it will combine all the image bounding box, and the majority of the region will be taken as an output of bounding box of the exact size. So to handle this will remove the overlapping bounding box. Then we can apply the non-maximum suppression. The ratio of overlapping between the bounding box and the suppression will give you the significant result of object area. So I tried to play this video. Okay, so if you see here, here the both object detection and segmentation plays a vital role, where the region of that particular object alone has taken, and it has been segmented, and it was shown in a bounding box. So object segmentation and instant segmentation was carried out here based upon the deep learning approach. So how it will be happen? So we will take, or we will take the predefined data set that was available for more number of some 10 to 20 labeled data. Then we will train the system to make it to identify or to create a model to perform well. Then we'll give this test data based upon the already trained model. This will classify and segment it and detect it. So the next one is face detection, and this is one of the very vast area, since the people and the machine was trying to give more number of papers in this face based application. So the left side image you can see here is the Facebook page of uploading the pictures. So I think this interface you would have noticed in 10 to 15 years before, when you are trying to upload a photo, this Facebook system will, we have to select the face, and we have to type the name of the person. But now if you see, if you upload a photo, it automatically identify the face, then it automatically say that you want to tag this fellow. So in that way, the face based application on machine learning was done. So this may happen, or this will be happen based upon the friends list and the list that we have already posted. So in that way, the machine was trained so that it automatically identify the face and it will show the result. So here the one of the thing I should say here is the nose part, mouth part and eyes part will be differentiated based upon the black and the white intensity. So as I told, to reduce the computational power, the grayscale color image will be converted into grayscale. So the range of values will be in 0 to 255 or 0 to 1. So the grayscale representation will be in a range of 0 to 255. And a theoretical face model of was given here with the 2 eyes, 1 nose and 1 mouth. So the mouth region will be differentiated by white, black and white. In case of nose, the horizontal position was shown here with white, black and white, and two portions of eyes which was shown here is with black and white. So in this way, the theoretical model will be designed, and once we are trained with the system, then we will make an input image or input video to perform the action of how our training was done effectively. Then I'll show you the output of that trained model of how face-based detection was done. So this is the Python code of how the face-based tracking was done here. So I'll run the code, then I'll explain how it was running. Could someone say that you can able to see my screen? Someone say, please, can you able to see my screen?
Yes, sir. Yes, sir. Proceed.
Yeah,
Sir.
yeah. So if you see this output file will give you how the face will be tracked in the face in a video. Yeah. So if you see some set of features was taken from the already trained image, and the given test image will be compared with that particular model to identify whether the given image or a given frame or a given video has some set of faces or not. So if you see this frame, some part of face was hidden by the hand. So in particular frame, that face was not able to track. So this is one of the main drawback of this methodology, because we have taken the eye part, nose part and mouth part, and if we are able to find these some set of values from this region, we can able to identify the face. But if you see this frame, some part of information was hidden, so that we are not able to identify. So this is one of the main drawback of this scenario, but still we are updating ourselves to make the performance much better. So and I will show I'll try to explain the code now. So if you see here, and these are the basic arguments will be used for importing the file, or for taking the input as a parameters. And import CV2 is the package that was used by OpenCV for image processing based techniques. Okay, so I have taken two parameters, one is input and another one is already trained hour-based frontal face classifier. So I have taken this as an input. So I have taken either by camera of my system as representing by CV2 dot video capture of 0, or I can taking in from the argument. So I have taken from the argument. Once I have taken the video, then the frames are extracted, and that frames will be converted into RGB to grayscale. So as I told, instead of processing in red color channel, we will be converting it to the grayscale value, so that the performance of computation will be very optimal. And once the RGB was grayscale was obtained from the color image, then we will be comparing with the already trained classifier of some scale vectors, and the bounding box region was obtained by this code, and the output will be available till the wait key is pressed. So this is the simple code of how the pre-trained classifier using hour based application was shown here. So this is the training classifier that I have used for training the frontal face alone, and this is the input I have taken, and this is the code in which we have seen. Then this is what we have seen this in this image. And so instead of taking less number of value, what we have planned is we have taken some 70 plus point from the face. So if you see here, we can able to take 70 plus points from the face based upon our scenario or our application. So suppose if you see, to identify whether the person is sleeping or not in the lab or in a semester exam, we can take only the eye region part alone. Or if I want to check whether the person is laughing or showing his teeth, I can take with the mouth region part alone. So if I'm going with any facial based expression, so each facial expression will have different set of values or different set of representations. So if we take sad or if we take excitement, that eyebrow region or eye region will be elaborated. So based upon that information, or based upon applications, the fiducial point accessing will be taken. So if we take this frame, as I told, 70 plus point will be taken from the face, so that the processing of applications of particular scenario will be used. So this was done for identifying the face, that is whether the shown face is a real face or fake face. So I don't know how many of them tried this. Most of them will have facial based recognition for unlocking your phone. Okay, so that you better you try that recognition system based with the image of yours to trying to open the phone. So if you do that, that phone will automatically unlock the phone based upon information. So but that should not be happen. So this is one of the example we were working on it, where to allow only to identify whether the given face is original face or a Xerox face or a phone or a spoof face. So the example I'll show here. So if you see here, the live face which was taken from the camera was shown as a live face, and once I show the face in a phone, it was showing as a not a live face. So how we have done the same thing? We have taken the input image, then we have obtained some set of feature value, then we have trained the system. So once these informations are taken, we will be giving a test video which you are seeing here. So we will be trying to classify the live face and spoof face, that is non-live face. So there were some variations. That's what I'm saying. The machine was trying to mimic or trying to compete with the human to give full potential result. So if I pass here, you can see some set of values were running at the background that will be estimated for a given video. Then that will be compared with the trained model, whether then I will be fixing a threshold. So if it is less than threshold, it will be a spoof phase, that is non-live phase, and the value that obtained is greater than threshold will be taken as a live phase. Simple. Yeah. So next one, this is one of the project that we have been used in our college to identify whether the person is sleeping or not in the lab or in the semester exam. So semester exam is little difficult because we cannot focus on the eyes of the students by placing a single camera. But in case of lab, each person will hold by a system, and if we import a camera before the system, and we can track the eyeball of the student, so then that eyeball region or the representation of P1, P2, P3, P4, P5, P6 values getting decreased, then we can say that the person, that the eyes was about to close, and we can easily identify that the person is sleeping. So then here we see the P2, P6 value will be compared, P3, P5 value will be compared, and the difference is getting reduced. Then we can identify that the person is closing his eyes, that is he was about to sleep. And this is one of the structure or step-by-step process in which the facial recognition was carried out. So if you see here, the face is captured, then the face alone from the whole region was captured, then the features are extracted, then that features will be taken for a comparison of already trained data set or already having data set to find the matching. So this is one of the good example is theft classification to identify whether the theft performed by the person is available in the criminal list or not. So that will make the police or current officials to make it identify very easily. So airport check-in, railway station, banking sector, stadium, public transport, and government official and business estimation are the very most scenario or thing where this facial recognition plays a vital role. And facial emotion, as I told, each shown the facial expression in the very first image, that is 7 classifications were shown. So each one, the variations of that fiducial point which I have represented or I have shown before will get varied. So if you see the first image, that lips region or the mouth part will be shrink or will be wide based upon the expression of particular person. And if you see the fourth image where the some part of teeth was visible, and if you see the sixth image, some part of mouth was very wide, so based on the eyebrow was little higher. So based upon this expression or based upon the values of obtaining from this, we can able to identify the facial emotion of the person. And the third one is video surveillance. So this is one of the very interesting topic, because we have to think as a real-time scenario how the situation will be happened, and we are trying to compete and we are trying to put forth all the advanced technique to make the scenario very protective. And this will be a secured blanket for a particular area. And why we are going with video surveillance, that is like will increase the public safety, and to find the trespassing and the crime rate, to reduce the crime rate, prevent the fraud, and to protect the assessed. And these are the areas where the video surveillance, that is VS, will plays a vital role in traffic monitoring, transport, in higher machinery and very mass companies, for manufacturing and protection, commercial units, stadium and public sector, education institution and government sectors, or even nowadays they wear surveillance camera in every 50 to 100 meters in all the roads and streets. So I don't know how many of them have noticed that. In particularly in Chennai, if you see, they were 50 to 100 meters length in duration. There were many traffic cameras over there. So, but still, government have increases the potentialness or to increase the security of the area, but still the crime rate and the accessing to the asset was still increasing. And so the trajectory representation plays a vital role in identifying the trace of an object. So let us consider here you see there were 5 cars and the trace of the car, that is path of the car, was shown here, so that whether that particular car will be taken, the information that available from the car will be taken for the further use. So the trajectory plays a vital role. So this is nothing but the trace representation of each object for a particular time frame. And this is one of the example of my research where we are working with vehicle based classification. So so our part here is to create a sensor. Here the sensor is a robot. So to make them to walk in a road to identify and classify the object. So this was done for a software based application. We didn't put it in hardware. So we are trying to put it in hardware to make the robot to work, to make the classification very better. So I'll run this video. So here if you see, the various classification of object was shown with the probability of nearing 99% of vehicle of such as car, truck, buses, person, and based upon the information of, if you see the probability range of capturing the object was shown with a number of less than 75 to greater than greater than 75 and less than 98%. And this is what we are trying to work with object classification to create a driverless car, or sorry, one of the add-ons for driverless car, or to intimate the blindness people to whether to identify what kind of objects it was nearing to them. And the next one is vehicle detection and tracking. So if I take any input frame, some set of foreground object will be moving in the frame, and the black and white image which was shown in the top right will be the white region or the foreground region, and the black or the background region. So once the foreground was estimated, and the second row first column image was shown a bounding box of with the location of x and y coordinates, and the fourth image, if you see, an ID was given to track the whole information from the entry to exit. Here the entry is top and the exit is bottom. And the next one is crowd estimation and traffic density. So this too plays a vital role in current scenario in India, where the estimating of crowd density is very lagging. I feel like very lagging, so that in case of any mischievous behavior or any abnormalities happened, then how the people will be segregated, or how they will make the person to escape. So that is one of the very much interesting real-time scenario. And another one is traffic density. So this you would have been seen in the GPS of all the mobiles, where the scenario of the traffic will be differentiated in various colors. So what we are doing is, suppose I am traveling from A to B. So in case in between A and B, if I find some very hard traffic or very heavy traffic, I should be given some other possible path of different way to reach B from A, so that I can able to reach the destination very easily. So that classification or that prediction have to be done very prior. And one more thing is, if I go in a cycle, that result should be based upon my scenario. So if I'm going with a car and the path shown by the optimal path shown by the GPS of which the cycle can go, then it won't be efficient. So that classification and prediction will be done in the traffic density based applications. The next one is pedestrian reduction, which I have shown in the before video. So here if you see the depth calculation between me and the front vehicle or front object was shown in a meters, so that suppose if a blind was walking towards the road, and the depth information or the distance information before the blind will be calculated, so that he or she can get alerted based upon the given information. So this is what we are trying to work on it. And driverless car based application. So if you see here, each and every information will be given to the car, so that the decision has to be taken by the car very potential and very fast manner. So if you see, if a car was going in 80 kilometer speed in a straight road, suddenly if it has to take a right turn which is in a 45-degree angle, that car should have to reduce the gear based upon some information obtaining from the viewpoint, so that the speed of the car will get reduced and the number of gear also will get reduced. So in this way, if you see, there is an algorithm called half line based algorithm, which will differentiate the white and the black region of a road. So if you think over the road scenario, where the road was divided into some lane divisions, so that should be in a white color and the road will be in a black color. So by applying this algorithm, we can able to mark the white region alone, and if we are getting any curve, and the curve angle will be predicted, and based upon the curve angle, the speed and the gear count will be get reduced or increased. So based upon this one example of how the speed control of the car will be taken was shown here. So if you see the right second row right side image, that is a Bosch car. So if you see that viewpoint which has two car and it was going in a bridge, so the yellow mark is the nothing but the representation of the white divider. So based upon that divider angle, the speed and the gear will be get reduced. And this is one of the example of unsupervised based learning technique of identifying the pattern recognition. So if you see here, the possible path of a particular scene was shown here, and the flexible patterns and possible patterns of a particular junction was shown here in some number as 1 2 3 4 5 6 7 8, and other path which is deviating from this possible pattern will be identified as abnormal. So for example, if you see a car, the possible pattern here, if you see the pattern which moves from 3 to 2 was not available in a B image. So if a car or any object making a U-turn from 2 to 3 will be identified as abnormal. And the same scenario in C images, so D images, where the pattern made by a car or an object from 7 to 8 will be identified as an abnormal, because that pattern was not available in the already trained pattern. So this is what how the possible patterns are grouped together. So in a left side image, if you see, the object was put in with the bounding box and giving an ID over there, and the trace of an object was shown in a right side image with the possible pattern, and they are grouped together based upon the flow and the closest group. So here if you see, they were they were 4 groups in which they have been grouped, and once they are grouped, and the pattern which are deviating from this will be identified as an abnormal. So these two scenarios are the top 2 images are the Indian data set, and the down 2 images are the somewhere in the China or somewhere in the countries. So if you see the above images, the accident was predicted since that particular action performing by the car and the two-wheeler in the A image was differentiating the learned pattern. So it was identified as abnormal. So if you see in the below images, the red color car was making a U-turn, which was not available in the possible patterns of the learned data. So that will be identified as an abnormal. So here the abnormal reduction is nothing but a pattern or a point or an object which deviates from the possible learned pattern will be identified as an abnormal. And this is one of the very much interesting, because we have to making a person sitting before a 10 to 30 cameras and make them to identify who are all making the abnormality, or what are the fishy happening. So instead of that, if you make the system to act intelligent, then the labor charge and the performance of the machine will be very high. And next one is driver assistance system to identify the performance of the driver based upon any scenario. So what we have done is we have placed a EEG signal in a seat so that the driver can interact with the sensor. So based upon that sensor value and the trained signal images, and we will be classifying and we will be giving an alert to the control office that based upon that performance, how the driver is reacting, or if there is any abnormal happening for the driver. So everything will be managed and it will be controlled. The next one is biometrics, which is very interesting, where because even the identical twins will have different set of values. So that will be a good example for this. And Aadhaar card, iPassword, authentication login or code, ATM credit card and debit card, airport checking, and even in many colleges biometrics plays a vital role. um, And so if you see this image, each patterns are very structured, and this will be computationally very less because the values that we are holding from the fingerprint is very less, and this is very powerful and easiest way to identify the person. As I told, this will vary for each and every person, and it won't be remain same for identical twins also. And different ridge patterns available from the fingers are bifurcation, short break, island, and the ridge ending. The core of the fingerprint pattern, the core here is the center part of the fingerprint, and the delta is where the ridges get divided. So if you see this 3 types, where arch, loops and holes are the 3 different patterns that we'll be having, and we'll have some different variations based of each and every person. So arches are nothing but the ridges, entry and exit on the same side. So if you see that image, it will be like a flow of entry and exit will be the same side, and loops is nothing but the entry and exit will be in a different side, and holes are nothing but there will be a circular mixture of pattern types. So these are the 3 type of patterns that are grouped. So a very good example of this important of fingerprint representation was shown here. So I think everyone can able to notice this. So when we are going with a fingerprint based unlocking your phone, very first time you will be given different set of values, that is the fingerprint values, by giving different orientations. Why we are going with different orientations? What is the importance of orientation? So whenever you are holding a phone, we won't have to hold in a fixed position so that to make the phone unlock. So that our fingerprint representation will get vary, not vary, the orientation will be different, so that the our phone will be in a position to identify our fingerprint to unlock it. So we'll take the image, then we'll segment only the fingerprint region, and we'll do normalization. So normalization here is nothing but to getting into all the values into a range of 0 to 1 to make the processing or to make the manipulation very effective. Then image orientation, here we will be fixing the phone in different orientations so that each information won't be get wasted. And image thinning and image filtering. So image image filtering here is to take only the exact region of the finger, and the filtering will be done. The thinning here is only taking the ridges of the fingerprint rather than other portions to make it track. So that's why you will be getting a red color change, increasing of red color change in each and every fingerprint give input data. And the image which going to scroll now won't give much information, because so this movie, that Indian movie will give, sorry, not Indian movie, I forgotten this name. It's Tamil movie, which give you the clear cut information of the importance of the fingerprint, where that particular information of identifying the thief was handled by the exact information of this Dheeram Adhikaram Ondru. Yeah, in that movie, if you see, that importance of fingerprint was shown here, and it will have high accurate and unique and economical technique, and easy to use, and it will have only a small storage space of particular values or particular region. And the next one is human activity recognition, which plays a vital role here. So in case of human activity recognition, we will extract some features from the video, and based upon the movements, based upon the collected movements, the particular semantic meaning will be extracted, and based upon that meaning, the recognition will be done. So each and every technique or each and every application will be in a flowchart of machine learning approach, but the scenario and the tech and the inputs we are taking from the features will get vary. So here everything will be in interaction based upon the two or more objects. So if you see here, the sports match of American football, where each and every position of the player was noted and analyzed. And the application of R here is for management, like counting the people heads, and automatic video organization, and pedestrian reduction, driver assistant, sports activity, human computer interaction, gaming, military and surveillance footage, and video, web-based video retrieval. So the next one is activity based upon the number of persons. So here the activity will be differentiated based upon the action performed by the object. So here the objects are three humans standing in a triangular shape, and they were speaking, and the features obtained from this group activity is in a circular motion that each one are speaking together. So that is an activity. So based upon this multiple action recognition will be done in a higher level. And the flowchart of architecture of HAR, that is human activity recognition, was shown here. From the input video, will be do some pre-processing, and background will be modeled, feature will be extracted, an object will be tracked, and based upon the information that we are obtaining from the tracking, the classification will be done, and the activity will be analyzed. So the pixel based processing, the first one is pixel based processing, where the persons are identified based upon background and foreground estimation, and the people are tracked based upon the skeleton based filtering, and the poses are classified. Once the poses and the skeleton informations are taken, then we'll be identifying the spatial and temporal modeling to to analyze the activity, and we will be visualizing it in a 3D or simple representation in a 2D. And if you take a human interaction, then if you see this slide will give you the clear information of how the person was trying to interact and how the model representation was shown. And human object interaction, so in this case the examples are robo interacting with the object, that is washing, driving, hair cutting, talking, so anything you can say. And human object, another example is how the human is interacting with the environment, the real human, how they interact with the real world. For example, how he is driving the car, or how he is interacting with the scenario like a game or something else. And if you take a Medicare, there are some hardwares where that will be act as an assistant to lead the person in a right way. So for example, blind person, or the person who are not unable to walk, that scenario, then the object and human will be get interacted. And activity context challenging here is activity involves interaction among human, object and scene. So here three particles we can say. One is human, object and scene. So here comes the concept of motion object context. So based upon the environment, that human will make some motion on the object to perform some actions. I think you can able to follow me. Based upon the environment, the human perform some action, so some motion on the object to make some action. So if we take any football game or any scenario of human object, some motions will be based, and based upon that motion, the pose will be estimated. So if we see here, there are different variations of cricket batting, cricket bowling, and tennis forehand, tennis serving, and volleyball smashing. So the relationship between the 2 or 3 motions were shown here. So if you see here, volleyball smash and tennis serving was shown here, and each have different set of motions particle based upon that context was shown here. So each of them will be segregated based upon the motion context, and the activity of particular object with some pose on that object was shown. Based upon this, the graphical model will be obtained, and since we are obtaining the structure of the pose based upon a graph based model, and each will be segregated based upon probabilistic model on dependencies. And the next one is group activity, whether the event will be done based upon the human group person interaction or group interaction. So if any meeting that was gathered by any politicians or any official meetings by any company, there we have huge number of mass focusing on a single object. So if we take any election meeting, so the point of focus will be on a single person or a single stage. So that is group person interaction. Or if you take any game based upon a group interaction or many number of persons, then that will be a group interactions. So based upon every scenario, our application will get vary, and the varying number of participants and dynamic spatial relationship between an object and the environment will get vary. And the challenges at each stages are background subtraction. So if you see a group to group interaction based scenario, each object will be very close enough to stand. So in that case, object subtraction or overlapping of object will plays a vital role, and feature extraction also a very key factor to make the extraction very effective to obtain good accuracy in learning. And deduction and tracking based upon partial occlusion also a challenges of this stage, and recognition performed based upon the features obtained for each action representation. So if some part of region was hidden by some other medium, then even the feature extraction tracking scenario or recognition part will be very difficult. And human behavior understanding. So each human will have their own representation of putting their behavior. So this plays a very vital role in identifying the person of how they are interacted. And so if you see, it's an open problem because this might be happen indoor and or outdoor. So we have to define an action, and we have to define how they are interfere with the other one, and whether we have a good visual clues of identifying an action, and we have higher level of reasoning why this person was performed this kind of scenario. So this everything we have to be considered to make a system or to make a mission to identify the behavior of the person. And here the labeling plays a vital role of each semantic video understanding. So if you take this one, the people one in the left side image has three persons where teases P2 and run away, and P2 kicks P1 and P3 stops fighting. So if you see here, there are different set of variations of actions obtained. So each actions has to be recorded and performed by the machine to react intellectual. And different scenarios where here is seen with a single person, that is pedestrian monitoring, motion monitoring, and supportive home nursing. So this is one of the applications where we are working on it, that the thing is to identify the heart rate and BP and blood pressure and sugar level of the person, to instead of making a nurse to sit along with the patient, 3 sensors will be placed the patient, and for every 2 to 3 minutes that particular information will be tracked to find whether there is any abnormal deviation in the particular patients. So this is one of the project where we are working on it. And outdoor scenario and crowd scenario will be plays a vital role in identifying the human behaviors. So if you see here, there were some objects available in a person were telephone, cell phone, human, chair, and suitcase. So each one are interconnected with the human based upon some operations. So in this way, if we perform the scenario based upon graphical representation model, then this will be very easily understandable. And so this is one of the example of how the background subtraction for object behavior or human behavior was shown here. From the input stream, the background was differentiated and foreground was extracted. By giving some thumb threshold, the foreground was extracted. And in feature based extraction, there are some features such as shift, hog, and NWFE and KLT. So each one plays a vital role in all HAR-based human activity recognition or group interactions or human behavior or vehicle based approach or any scenario. These features plays a vital role in obtaining optimal features. And the body part estimation was shown here, where if you see in the top right image, where each segment of the parts of the body was shown, and each dot was nothing but the joints where the motions are extracted. So if a person was about to give a slap or about to kick up another person, each variations will be noted based upon the joints available in the body. And the pose estimation of different representation was shown here in the image, and the silhouette here is nothing but only the region of the pose will be taken, and the pose representation here is the whole region will be taken by a key point of single point, and the sequence of key pose is nothing but how the pose is estimated, how the pose is obtained for some set of frames. And object representation with an example was shown here, that is the object will be represented by a single point, that is centroid, or by multiple point, or by rectangular patches or elliptical patches, and body parts multiple patches, or object stationized representation, center point, control points of the object contour, and the complete object contour and silhouette of the object. So if you see this 9 representation, each representation will be used based upon the application. So if I take the A image center part, if I am working with the global representation of the body, because I'm no need to concentrate on the interior representation, I want to analyze that there were some particular action was happening and I want to analyze that. If that is a scenario, then a centroid based tracking is efficient. Suppose if you're using with a vehicle based application, you can go with the rectangular patches. So if we see the parts based multiple patches, I need to concentrate only on the hand based motion, then I can go with part based multiple patches or object skeleton based approach. So based upon this, the parts will be taken as a single movement, and there were some many algorithms, that is graph based model or skeletonized or segmenting based upon a hierarchical based model. Based upon that technique, this particular motion of the parts alone will be tracked. And the human body representation was shown here, and motion history and optical flow features are these two representation plays a vital role, where this motion history volume and optical flow features will give you the representation of angle direction in a magnitude and displacement. So if I want to work with the speed of an object, or in what speed the particular object was moving, I can go with motion history volume or optical flow features to represent the over speed of the vehicle. And in that way we can see, and a skeleton based and body model was shown in second row last image, and each node will be the joints that were available. And activity classification were simple task to identify in video. Here the categorization plays a vital role of push, punch, kick, shake and hug are a 5 classification, and based upon the limited number of data available for each classification and the interaction among the people, and this activity will be classified. And if you see this image, this slide, the activity here was shown is punching, hugging, handshaking and punching. So the input video which I am getting will be come under or will be fall under any one of the classes. So if the interaction is closely associated with any one of the group, then the particular frame will be taken as that particular activity. And this is what shown in a video. So starting time and ending time will be taken, and the continuous frame differencing will be taken to identify the human motion. Once the human motion is done, based upon the skeleton approach, the interaction between the 2 or 3 objects will be analyzed and will be predicted or identified in which class they are coming under. And activity based upon robo will be coming under the robo vision, and the tasks such as hurdles identification or effective path planning and manufacturing company, this robo plays a vital role. And so this is two important scenario where in Chennai a robo theme based restaurant was invented, where the serving will be done by the robo for each and every customer. And the maze game was shown here to find the path efficiently to reach the path by the estimated time. And this two example which we are seeing from the first, that is Indian movie, where the left side image, if you see that robo was making a operation to make a baby to coming out. So in that scenario, if you see that robo, by touching his hand on the stomach of that lady, it will estimate the predictive time of that baby that going to come out, and what is the current scenario of the inside the womb, and also it will telecast that information to the TV. so that everyone can able to visible. So that these type of informations will be done based upon the learning scenario that robot taken in the very first scene of the movie. So if we take the right side image, um, this scenario is nothing but like that robo will make a rescue of a girl from a building. So in that scenario, if you see that hero will ask him whether you will be in a position to do that operation. For that, that robo will sense the environment, and then it will say the heat capacity is this, but I have the capacity greater than the current capacity. So I can able to make the rescue. So that kind of prediction based upon the environment, and it will automatically adapt to the scenario, like changing from the normal dress to a full metal dress. So in that way, the machine will act intellectual to make it to adapt themselves to the scenario. And medical image processing based application here, this is one of the very vast and very interesting next to face based applications, where they are having some sequence of steps where image acquisition, that is image acquisition is getting an input image, then we'll do some image enhancement, because the image that we are getting will be in a grayscale. So we will do some image enhancement of increasing the brightness or increasing the size of the image. Then we will do some segmentation. So here the segmentation part is comparing, instead of getting focusing on the whole image, I will be focusing on the particular region where I need to work. So in case of kidney based applications, I should be concentrating only on the other region. So segmentation part of identifying the kidney or any organ plays a vital role. Instead of identifying the kidney for kidney application, if you're working with identifying the pancreas and working, then it won't be give meaningful. So the segmentation part plays a vital role. Once the segmentation was done clearly, then identification or deduction of particular cancer or particular meaningful information will be done. Then analyzing the cancer or analyzing the information on in what stage the particular disease was, or in what stage the particular information was. So then the diagnosing part will be done. And so if you see here, the applications of medical image processing are shown here: diabetic retinopathy, breast cancer, brain tumor segmentation, prostate segmentation, and kidney segmentation, and automatic segmentation of tumor cells. So if you see in the three images, the brain part, instead of concentrating on the whole brain part, I should be in a position to write a code or to perform to access only on the region of particular tumor or cancer. So that should be plays a vital role in how the training system of your algorithm should be. And the remote sensing based applications in machine learning here is based upon the sensors or satellite, the informations will be taken and that will be transmitted to the information center, and from that analysis we will be categorizing the data based upon the information that we have got. So good example for this is Osama was assassinated by the US Army without getting into the region of Pakistan. They have they have collected all the information from the satellite without coming to the nearby place. Then they have estimated everything. Then they have came and did whatever they want, whatever they did. So this is a good example where all the information will be transmitted to the satellite. Once they get transmitted, this will be taken for further analysis. And another good example here is forest fire, and also for cloud density estimation to identify the rainfall and the sunny forecasting, and for agriculture based manufacturing estimation, whether because if person is having some 10,000 trees, it is very difficult for the person to get around for everyday morning to identify the healthiness of the tree. So instead of that, the, the information that transmitting from the satellite will be taken, and he or we will be developing a system to identify whether the particular region of agriculture or farming is very effective, or I need to perform any other remedy for any infected scenario. So these kinds of applications, that remote sensing plays a vital role. And I have done, and if you have any questions, you can ask me now.
Thank you, sir.
Thank you, ma'am.
It was a wonderful and effective session. And I sincerely thank you for sharing your knowledge and ideas regarding this topic. And the participants, if you have any queries, you can unmute yourself or you can type in the chat box.
Hello, good afternoon, sir.
Yeah, good afternoon.
Hello.
Yeah, please.
Sir, misbehavior detection using the human in the traffic scenes. How? Which method is the best for, sir?
Misbehave in the sense, what kind of misbehave you want to identify?
For example, accident is accident is happened.
Okay.
Yeah, automatically it want to be detect that.
I can understand. Yeah. See, the first and foremost thing I try to say is, you try to relate everything in a real-time scenario. So you just think it in a practical scenario of how the structure of the road will be. So there will be some motion patterns from top to bottom, bottom to top, left to right, and right to left, right? So
yes, sir.
Yeah. So based upon the learned patterns, we can go with unsupervised based learning. Because why I'm saying is, if we take any scenario, the data which we are getting from the scene of normal will be more than the abnormal, right?
Okay.
So we'll get more normal data than abnormal data. So with this ratio of data, if you go with the supervised based learning, it won't be effective. So instead of that, if you take the normal data, then train the system based upon unsupervised based learning, such as k-means clustering, hierarchical clustering, density based. If you want, you can note it down. K-means clustering, hierarchical clustering, density based clustering, or data field based clustering, or spatio-temporal based clustering. So these are the many type of clustering techniques available to make the system to learn efficiently to work on it. Okay.
Okay. And one more thing, sir.
Yeah.
At a time, how to detect that objects plus human? That means things.
You need to classify it or to detect it.
Detect it, sir.
Yeah. Okay. So if you go with the background based subtraction, what are all the objects moving in a image, moving in a video, will be identified as a foreground image. So the rest of the image will be taken as a background image. So obviously in a road, vehicle will move, a biker will move, a cycle person will move, or pedestrian will move. So based upon the differencing between the first frame and the current frame will be taken by based upon GMM algorithm.
GMM algorithm.
GMM, Gaussian mixture model, adaptive model, optical flow, motion contextual technique. So based upon this methodology, the foreground, that is moving object, will be identified.
Okay, sir.
Okay.
Sir, yeah, I'm doing research on this only.
Okay.
If you have any like a email ID, if you share, no, sir, it's more helpful for us.
I'll share you at the end of the session, ma'am, because many questions are waiting. So
okay, thank you.
For that, I'll share you.
Sir, someone is asking you to share your presentation from Tirunavakar.
I haven't shared, ma'am. It was shared only. My script.
I guess they are asking to share through mail.
Okay, I'll send you, ma'am. I'll send you to Jaychandran sir, and he will do that.
Yeah, okay.
Okay. So, ma'am, I have seen many questions. Shall I read out and I'll give an answer for that, ma'am? Or
Sorry, sir.
ma'am, there were many questions in the chat box.
Okay.
So, shall I continue with that question?
Yeah, you can just do their
Yeah,
queries.
ma'am. Yeah, ma'am. So, I can find Tirunavukarasu that in OCR using machine learning for Tamil text is possible. Which algorithm is better, sir? Yeah. See, whatever thing, if you have data, the machine learning is possible. Simple question, simple answer. So if you have data for a Tamil text, then you can perform machine learning to make the prediction effectively. So based upon the data we are acquiring, you can go with supervised based learning like HMM, KNN, then extreme learning, then support vector, then one class SVM. So based upon these kind of algorithms, the OCR for Tamil text based application can be done. Then one more question, which algorithm is used to extract the retinal blood vessel in retinal images, and how to find the blockage of vessels in the retinal images? So if you see, there were informations available in the hospitals where the retinal part information alone can be taken, and the veins can able to identify based upon edge based extractions. So the edges, what here will they do is they will extract the vertical and horizontal lines, and if there is any big region available in the vessels, then we can take it as a blockage to work on it to identify what stages of blockage is there. So that can be done. And that's all the question, ma'am. And if anyone is willing to ask, they can, ma'am.
Okay, sir. And in chat section somewhere asking for feedback form or else attendance form, but here we consider only the amount of time in each individual has spent in this webinar. So based on that, we'll provide the e-certificate. So there is no poll or attendance form or feedback form. So I just answer for them. So is there any queries from the participants? So, okay, I hope that there is no queries. And from Sudha, there is a question. So I've answered for that. Based on your amount of time spent, you will be provided. There is no separate attendance link and all.
Okay.
So I hope there is no queries, sir. So thank you very much, sir. It was an interactive session, and I hope everyone had some knowledge. So I'll just wind up this session, and we'll meet in the next upcoming session. So thank you all.
Thank you, ma'am.
Thank you, sir.